Hi guys, Mr. Thompson again. Today we're going through lesson 10, session 2 in our Ready textbooks, page 187 to 192. Alright, we're going to start off with a little brain teaser like we always do. 4 familiar boxes, 4 familiar letters, and 4 familiar expressions. Okay, this is a which one doesn't belong. As you can see, we have 4 different expressions. 3 of them have something in common, 1 of them do not. Try to find something that each of those 4 don't have in common with the other 3. So give it a second, write it down, and I'll see you in a little bit. Alright, welcome back. So what solutions did you come up with? Well, if you notice, box A is the only one that is a positive first addend. The others start off with a negative integer. B is the only one of the 3 that has a positive value. If you solve all those, then A, C, and D come up with negative answers, and B is the only one that has a positive answer. Did you come up with that C is the only one that's the sum of 2 negative numbers? What? Well, what about D? No, D is the subtracting 1 negative and 1 positive number. And D, in fact, is the only subtraction expression in that whole thing. So, if you found those, good job, you're on the right track. So, let's continue onwards into our textbook. Page 187 to 192. So we'll start off on lesson 10, session 2. So we're subtracting positive and negative fractions and decimals today. We're moving from the integer world into the rational world. During December, the sample problem asks, the average daily temperature in a town is negative 1.7 degrees centigrade. The average daily temperature in the same town is 3.2 centigrade lower in January. What is the average daily temperature in January? So what are we looking at here? Well, we know that the daily temperature is negative 1.7 degrees. Now we know that the daily temperature in January, that was in December, in January it's 3.2 C lower. That means the daily temperature isn't 3.2 degrees. It means it's lower by 3.2 degrees. So, how would you solve that? Get a few ideas down on paper, put me on pause, and come back when you're ready. Alright, welcome back. Let's see what we have here. Here's what I came up with. So let's take a look here. So as you can see, we've started with negative 1.7. There's a temperature we started with. And it goes down by 3.2 degrees. It's 3.2 degrees lower, right? Now that means we can change this from subtracting a positive number to adding a negative number, right? That's the second step here. We've changed this to negative 1.7 plus a negative 3.2. Now, notice what I've done next. I've decomposed these numbers. I've broken that negative 1.7 up into negative 1 and negative 0.7. And I've broken the negative 3.2 up into negative 3 and negative 0.2. Why have I done that? So that we can recombine them, of course. And since we're adding all of these terms together, it doesn't matter what order we add them in. So we can swap stuff around. That's exactly what we're doing. We're going to take this negative 3, this integer, move it over here with this negative 1. And then we're going to take this decimal and move it over with the other decimal. So negative 1 plus negative 3, you know what that is? You're adding 2 negative numbers together. So if you go to negative 1 and go negative 3 more, you're just going more negative. So we're adding those together. Negative 1 plus negative 3 gives you negative 4. There's negative 4. Negative 7 plus negative 2, well, that's negative 0.9, of course. Put the 2 together. Negative 4 plus negative 0.9, well, that's just negative 4.9 degrees. And that's what you get. Negative 4.9 degrees Celsius is your average daily temperature in January. Now there's another way you could have done this too, right? If you wanted, you could have used a number line. And there's an example of that. If you wanted to show it on the number line, you could say that, oh well, we start at negative 1.7. That's right here, because 0 is way up here, right? So we're down at negative 1.7. From negative 1.7, we drop another 3.2 degrees. So we're subtracting 3.2 degrees from that, or adding a negative 3.2. And so if you add negative 1.7 and negative 3.2, you get to negative 4.9. And that's our spot right down here in the number line. So you can look at it like that if you wanted to. So how'd you do? Pretty good? Good. All right, let's look at the next one. On our next page, on page 188, if you look through this, it shows you basically what we just worked through on the other page, isn't it? It's walking through that temperature, about the daily temperature in town. And there's two different models, right? The first model is doing it mathematically like we did. Notice they're doing it the same way too. They're starting at negative 1.7 and it's dropping by 3.2 degrees, so they're subtracting 3.2. They also rewrote that as plus a negative 3.2 here. And then you work out negative 1.7 plus a negative 3.2. You're just adding these two things together, right? Add 1.7 and 3.2 and you get 4.9. And the same idea holds here. This number line is a lot more accurate than the one I had. As you can see, it starts right precisely on negative 1.7, drops exactly 3.2, and ends at negative 4.9 right there. You can count that down by tenths if you wanted to, and it would get you right there. Not going to spend too much time on that page since we basically talked about that in the previous page. So let's move forward to page 189. Have some connect it problems. Look at the first to model it. That's the one that we did that was both adding and subtracting, right? Changing the number, changing the sign. Why can you write both an addition expression and a subtraction expression for that situation? How would you write that down? Well, you know that if you add a negative, you're just subtracting a positive, right? If you change the operator, then you just change the sign of the number that's next to it. So adding a negative, subtracting a positive. Adding a positive, subtracting a negative. Subtracting a negative, adding a positive. So what can we say that? We can say it just like this. Adding a negative is the same as subtracting a positive. Let's look at number 2. Let's look at that second modelet. That was the number line. How does that number line represent both the addition expression and the subtraction expression? Because think about that. If we've changed it from adding a negative to subtracting a positive, we're still moving in the same direction. Why is that? How would you write that down? Have any ideas? Here's my idea. How about this? Whether you subtract a positive number or add a negative number, you're moving towards the negative side of the number line each time. So you know about subtracting a positive number. You have the positive sign, and you have the negative, and it's going backwards that way. Now if you're adding a negative number, you're doing the same thing. You're just moving more towards the negative side of things. What was the average temperature in January, says question 3. Remember what that was? It was 4.9. Moving on down to question 4. How is adding 2 negative decimals like adding 2 positive decimals? And how is it different? So you have two negative decimals and you're adding them together. How is that like adding 2 positives? What do you think? Well, you can think about that. If a negative number is the opposite of a positive number, if you add 2 negative numbers, it's just like you're adding, except you're finding the opposite answer, right? You're finding the answer on the negative side of the number line. So we can think of it kind of like this. In both cases, right, both in adding 2 negatives or adding 2 positives, you're moving the same direction on the number line. The negative decimals move in the negative direction down the line, and positive decimals move in the positive direction down the line. That's why 5 plus 5 is 10, but negative 5 plus negative 5 is negative 10. It's the same answer, it's just its opposite. Question 5, kind of related to that. How is subtracting a negative decimal like subtracting a negative integer? Well, the only difference between a decimal and an integer is that one is a decimal and one's an integer. In both cases, you're subtracting like you're adding the opposite. And in both cases, the answer that you get is greater than the number you start off with. Right? Because subtracting a negative is like adding a positive. So 5 minus a negative 5 would be 10, because it's 5 plus 5. And the reflection, of course, as always, we'll keep the reflection just for you. Let's look at our next page. Let's go to page 190. Let's do a couple examples together. Okay, on Monday, the low tide at Cook Inlet, Alaska is negative 1.5 feet. On Tuesday, the low tide is negative 1 1/3 feet. How does the low tide on Tuesday compare to the low tide on Monday? And show your work. Well, let's take a look at this. So what is it asking us to do? Well, on Monday, we're negative 1.5 feet. On Tuesday, we're negative 1 1/3 feet. Now, what do those negative feet mean? That means it's below sea level, right? So low tide is 1.5 feet below sea level. And on Tuesday, the low tide is 1 1/3 feet below sea level. So we're comparing. How does the low tide on Tuesday compare to the low tide on Monday? Well, if we're comparing something, we have to find the difference, right? And if we find the difference, that means we got to subtract. So let's see what our subtraction would look like. And here's what our subtraction would look like. So we start off with 1 1/3. There we go, that's our low tide on Tuesday. And we're finding the difference, so we're subtracting negative 1 1/2, which is a low tide on Monday. Now you're subtracting a negative, that means you can change that to a positive, right? Because subtracting a negative is the same as adding the opposite. The opposite of negative 1 1/2 is 1 1/2. So that gives us a negative 1 1/3 plus 1 1/2. Now, we can add these two things together, but not without making common denominators out of them. So let's make common denominators out of these. So the first thing we'll do, let's make these mixed numbers. So we'll take negative 1 1/3 and go 3 times 1 is 3 plus 1 is 4, so that's negative 4/3. And then 1 1/2, so 2 times 1 is 2 plus 1 is 3, so that's 3/2. Now we got to get that common denominator. And the common denominator between 2 and 3 is going to be 6. So to get from 3 to 6, you multiply 2. So if 3 times 2 is 6, 4 times 2 is 8. That gives you negative 8/6. And if 2 times 3 is 6, 3 times 3 is 9. So that gives you 9/6 over here. So now we have 8/6 plus 9/6. And if we have 8/6 plus 9/6, well, how would you find that? Well, negative 8 plus 9 is the same thing as 9 minus 8, right? 9 minus 8 is 1. So if you have 8/6, you add 9/6 to it, that'll get you on the positive side by 1/6, right? In other words, you can subtract these two numbers, 9 minus 8. Which one of these numbers has the largest absolute value? Well, it's 9/6. So 9/6 is a positive number, so that's how you know. That's how you can check yourself, to know that that 1/6 is a positive 1/6. And so the low tide on Tuesday is 1/6 of a foot higher than the low tide on Monday. So that answers that question. Let's look at number 8. Number 8, that's an easy one. We are finding 3 1/4 minus 4 1/2. And show your work. So, how would we find 3 1/4 minus 4 1/2? Well, it's kind of like what we did with number 7, isn't it? What we can do looks like this. So we started off with 3 1/4, and we're subtracting 4 1/2, right? Well, first thing let's do, get these from mixed numbers into improper fractions, and then get a common denominator. And we can do that because 3 1/4 as a mixed number is 4 times 3 is 12, plus 1 is 13, that's 13/4. And 2 times 4 is 8, plus 1 is 9, that's 9/2. If it's 9/2, 2 times 2 is 4, 9 times 2 is 18. That gives us 18/4. So now we have 13/4 minus 18/4. And we can make that into an addition problem by saying 13/4 plus a negative 18/4. All right, now we got 13/4 plus a negative 18/4. We know that when we're adding or subtracting fractions, our denominator doesn't change. So we can just think about that 13 and that negative 18. So let's subtract those. 18 minus 13 is 5. But which one of these fractions is the largest absolute value? It'd be the negative 18/4, because 18 is larger than 13. So that means that negative is going to carry through to our answer, and that 5 is going to be a negative 5/4. Remember, because we're finding per fourth. And negative 5/4 is the same as negative 1 1/4. And that is your solution to that question, negative 1 1/4. Let's do another one. Here's number 9. Find 5.4 minus 7.1 and show your work. Well, that's going to be pretty easy, isn't it? That's just 5.4 minus 7.1, which is the same thing as 5.4 plus a negative 7.1. So what's 5.4 minus 7.1? Well, we're subtracting, right? We're finding the difference. So we have to find 7.1 minus 5.4. We work that out, right? 7 goes to 6, carry the 1. 11 minus 4 is 7, and 6 minus 5 is 1. So 1.7, but is it positive or negative 1.7? Well, let's look over here and see what the number with the largest absolute value is, and it's negative 7.1, because 7 is larger than 5. So that negative with the 7.1 carries through to the answer, and our answer is going to be negative 1.7. So negative 1.7 is our answer for that one. Still making sense? Good, good. Now let's take a look at page 191. Up into the green pages now. That means it's up to you. Let's take a look at our question for this. A path from a dry lake bed starts at an elevation of negative 12.5 feet relative to sea level. The path ends at an elevation of 60 1/3 feet above sea level. So what number represents the change in elevation from the start to the end of the path? And so to find the change in elevation, you're just subtracting, right? Because you're finding the difference in the elevations. So 60 1/3 is where we ended up with. Negative 12.5 is where we start. Since we're finding the difference, we're subtracting. So 60 1/3 minus a negative 12.5 is the same thing as 60 1/3 plus 12.5. Hey, that's easy to do. That's just adding. So we find ourselves common denominators. 60 2/6 plus 12 3/6. Add those together, and that gives us 72 5/6. So that represents the change in elevation from the start at negative 12.5 all the way up to 60 1/3. So it says you can also find 12.5 minus 60 1/3 equals negative 72 5/6. So what information does that give you about the path in the example? What do you think? What's the difference in this and what we saw earlier. We're starting at 12 and a half, we're going to 16 and a third. Well, this is positive 12 and a half minus 60 and a third. And the answer is negative 72 and 5/6. Well, before we found the change in elevation from the bottom of the path up to the top, right? This tells us the change in elevation from the top of the path down to the bottom. So we can write that in a way that looks like this. It just tells the change in elevation from the end of the path back to the start, because it's a decrease of 72 and 5/6 feet. All right, same idea. The lowest point in that dry lake bed in the example we just looked at has an elevation of negative 18 and 3/4 feet. What number represents that change in elevation from the start of the path to the lowest point in the dry lake bed? And show your work. So I let you do this one. So try it, see what you can do. We'll come back in a second. All right, welcome back. How'd it work? So did you realize that to do that, you're finding a change in elevation from negative 18 and 3/4 to negative 12 and a half. So you're finding the difference between those, which means you're finding a subtraction of a negative, which means we can make that into an addition problem. Go to negative 18 and 3/4 plus positive 12 and a half, because subtracting a negative is the same as adding a positive. We've got to find some common denominators again. That's easy enough, because 4 is a common denominator, so 18 and 3/4 stays the way it is. 12 and a half changes to 12 and 2/4. And if we're subtracting these two, we don't really have to make mixed numbers. We can decompose and do it that way. Because if we're going from negative 18 to positive 12, we can subtract that. 18 minus 12 is 6. And 3/4 minus 2/4 is 1/4. So 18 and 3/4 minus 12 and 2/4 is 6 and 1/4. Now, is it a positive or negative 6 and 1/4? Well, we look at the number with the largest absolute value. The largest absolute value here is 18, because 18 is bigger than 12. So that means this negative with the 18 carries through to the answer, and we have negative 6 and 1/4. So the elevation from the start of the path to the lowest point in the lake bed is negative 6 1/4 feet. What do you think? Did pretty good? Let's move on up to number 3. Okay, what is 2.6 minus 7.3? And show your work. What do you think? Give it a shot. Be back in a second. All right, I'm back. How'd it go? So 2.6 minus 7.3, that's a pretty simple subtraction problem. Let's make it into an addition problem. To do that, we have 2.6 minus 7.3. We make that into 2.6 plus a negative 7.3, right? So to do that, since we're going from a positive and adding a negative, that means we're subtracting these two numbers. So we subtract 7.3 and 2.6, and 7 goes to 6, carry the 1. 13 minus 6 is 7, 6 minus 2 is 4. So that means our answer is positive or negative 4.7. Which is it, positive or negative? Well, looking over here, what's the largest absolute value we have? It's negative 7. 7 is larger than 2. So that means our negative stays with our answer, and our answer is negative 4.7. Of course, the way that works is, if you're thinking of a number line, if you have positive 2.6 and you're taking away 7.3, once you take away 2.6, you still have more to go, but now you're on the negative side of 0. That's why the largest absolute value carries through to your answer, because that tells you if you're going to be on the negative side or the positive side of 0. Let's look at this one, number 4. When Daria gets to school, the temperature is 5.7 degrees Fahrenheit. Cold. The temperature changes by negative 9.5 degrees Fahrenheit by the time she goes to bed. Even colder. What is the temperature when Daria goes to bed? And show your work. Well, if the temperature is 5.7 and it changes by negative 9.5, that means it's going down 9.5. So that means we can have 5.7 minus 9.5, right? Because we're finding the difference and our change is in the negative direction. So what would that look like? Kind of like that. We have 5.7 minus 9.5. As before, we have 5.7 plus a negative 9.5. So if to find out, since we have a positive and a negative added together, we can subtract those. 9.5 minus 5.7. 9 goes to 8, carry the 1. 15 minus 7 is 8, and 8 minus 5 is 3. So our answer is going to be positive or negative 3.8. Now, is it going to be negative or positive? Let's look at our numbers. Pick the one with the largest absolute value. That's negative 9.5, because 9 is greater than 5. So our answer is, again, on the negative side, negative 3.8. All right, let's finish up with 192, question 5. Last one. An otter is swimming at negative 4.2 yards relative to the surface of the water, which means he's underwater. Otherwise he'd be flying, and otters don't fly. So he's negative 4.2 yards relative to the surface. He dives 8.6 yards deeper down. So after the dive, what's the otter's elevation relative to the surface of the water? So this you have a negative number, negative 4.2. And then the otter's going deeper than that. So what do? Add, subtract, multiply, divide? Who knows? It's up to you. Give me a pause and come back when you're ready. Okay, we're back. So we're swimming at negative 4.2. We go down 8.6. That means we're changing elevation further down, right? So that would look like negative 4.2 minus 8.6, right? Here we go, negative 4.2 minus 8.6. Make that into an addition problem, so we have negative 4.2 plus a negative 8.6. So that tells us we have two negatives added together. So we can just add these two numbers, right? Because if we have a negative and we add another negative, we're just going more and more negative. So we can add those two numbers because it's just the opposite of an addition problem. So 4.2 plus 8.6. 2 and 6 is 8. 4 and 8 is 12. So our answer has to be negative 12.8. Why is it negative 12.8? Because we just keep going negative, right? He's down below the surface. He goes down further below the surface. And he ends up at 12.8 yards down below the surface. And that, my friends, is session 2. Join me again tomorrow when we'll work on lesson 10, session 3. And until then, I'll see you guys later. Bye.